Find first 10-digit Fibonacci number. If this question comes to you, then get into the mind. Key recruiter want to know your knowledge about the recursive and iterative. Fibonacci number everyone knows. Let me revise what is a Fibonacci number. Here 0 is not there. Consider this is a 0 at the 0th index. If we do 0 plus 1, it will be 1. Next number will be generated as 1. So every number is generated by last two numbers. The same very famous recursive solution of this Fibonacci sequences. First is this recursion relation, that is, suppose I want to find this third index, then what should I do? I could know the first and second index so that I could get the third index by just n minus 1 and n minus 2. This is what the recursive relation about the Fibonacci number. But what is the trick? What they want to ask you here exactly? So you can see that here this is all other one digit number. This is like single digit number, and here it is a two digits in a number 13. And when it has come at the index, which index? Suppose this is first index, and second, third, fourth, fifth, sixth, and seventh. After at the seventh index, we got the 13. And the same when we try to get the three digit number, we could get at the 12th index. This is the 12th index where we'll got a 144. Okay, and now question says, what are the major tasks? We need to find the index of first Fibonacci term that contain a 10 digits. Means here we are satisfied with the 3 digit and we want to find the number with a 10 digit. If we tried using a bottom-up solution, what will be the problem with a bottom-up solution? Bottom-up solution need to know the ending point so that we could recursively track from the bottom to the first index, right? So this here we don't know n. Here we don't know where the nth number is, and for this approach will won't work. In the top-down approach, what happens is you need to call a recursively, and here the number is so big enough, that is 10. Why it is big? For your kind information, the 10-digit number will occur at some around 42 index. So 42 index, then you can have in mind that 42 recursive calls will be there, and backtracking them back to the zeroth, thus all 42 index in a memory or in a stack will definitely high uses of a space. So please do not opt for the recursive solution, and you will explain to the recruiter same this way that why a recursive solution won't work here. So this is what discussed here in the brute force. What task we have to do? First we need to get the series, and suppose here I got the third one, like here I got 3, then I need to check how many digit it has. Suppose I got 34, how many digit is it? Has 2 digit, and we need to check whether this is a 10 digit. No, if not, then continue generating series. This iteratively works so good enough. Let me show you. I am showing here a directly code which will help you to get the exact logic. Here I have a is equal to 1. Like I am starting from the second index, as I have earlier said. That is 1 plus 1. I will get the third index is 3. Number as a 3. Now, rather than using the function count digit, which will again take n complexity, what we simply could do, we convert this into the string and check the length. So this will saves us n square complexity to the n complexity, right? So let me dry run this for you, and you will help you will get the exact algorithm for this solution. Here we are starting our Fibonacci series. This is the same code as a Fibonacci series. Now we have a is equal to 1 and b is equal to 1 here, and my index is 1, Fibonacci series is 1, digit is 1. Then comes to the second index, I got the 1 because 0 plus 1 is equal to 1. Now here starting from the third index, what you will see that 2. How? 1 and 1 by a and b, because my earlier a has 1 here, like whatever we are starting from this index, right? Now when we come to the this is the 2, we'll hold this value into the my b is equal to 2, a is equal to 1. Now fourth index will be 3 because 2 plus 1 is equal to 3, a is equal to 1 and b is equal to 2. Now we'll count the length of string, which is 1, and we are again incrementing our index and putting the values back to the means whatever my new generated value is in the b and b's value into the a, and this how we are generating Fibonacci series until we got the length of a 10. Here is what the exact idea, we can say, not an algorithm. And time complexity as discussed, O of n, not O of n square, because we have reduced the time by making it into the string and computing length rather than counting the digits from 0 to 1. Okay, and the space complexity is absolutely O of 1 because we are not using any extra space here. So let's meet at the next video.